Okay, here we are at Chapter 1 and Section 1.1 to 1.4 test. So let's go through the beginning. It says to evaluate the exponential expression, which means just simplify this, figure out what this answer is right here. Well, it's a -2, it's in parentheses, being taken to the fourth power. So it means we have to take everything in here to the fourth power, including the negative. So watch, remember, if I have an even exponent right here, if I have a negative inside this parentheses, it's a -2. It's kind of like paired. Every time it's an even number, 4, 6, 8, 10, whatever, 2, it's paired up. Every time you have a pair of negatives, that becomes a positive. So every time you have a parentheses with a negative inside of it, and this is taken to an even exponent, 2, 4, 6, 8, 10, this is always going to come out positive. So that's all I got to worry about, that it's going to come out positive. Now I take the 2 to the fourth power. Well, 2 to the fourth is 2 times 2 times 2 times 2. All right, 4 times. You can do that in your head. 2 times 2 is 4. 2 times 2 is 4. So 4 times 4 is 16. So 2 to the fourth is 16. That would be a little different if it was this. Now this is not the problem, okay? I just want to show you the difference. Right here, you're not taking the negative to the fourth power. The only thing that's being taken to the fourth power is the 2. So this negative just stays out in front, and then you go 2 to the fourth. We already figured out 2 to the fourth is 16. So if you had a situation like this, it would be -16, not +16. Okay, number 2. This is order of operations, and it says use the order of operations to evaluate the expression. So just figure out what the answer is to this. The key to this is to know which ones to do first. That's why they call it the order. What order do you do first? We always do multiplication first. Remember, please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. So we do multiplication before we do any addition. So that's why we're multiplying these things first right here. So let's just do it. 14 plus, and then let's see, that's 16, that's 160, and then plus 9. Alright, let's figure out what this is. Let's do 14 and 9. 14 and 9 is 23, and you add 23, and that would be 183. Of course, you could always do that on a calculator, but make sure that, I wouldn't always trust just putting this straightforward in from the calculator. I would make sure that you know that you multiply first before you add and subtract. Alright, the next one says evaluate this expression. And it's 8x minus 9y minus 3a, and they tell you what x, y, and a are equal to. So it's basically just substitution. We take the x, we put it in every time we see an x. Or the -2, put it in every time we see the x. Take the 3, put it in every time we see a y. -4, put it in for a. So this is what I do. Whenever I see a variable like this, I always put that in parentheses. So it's 8 times x. What is x? It's -2. I think that parentheses is very important. I'm going to do that every time. Minus 9y, well, y is 3, so I put a 3 in here. Minus 3a, so it's -3, and then times a, which is -4. Alright, let's do these multiplication problems first. 8 times -2 is -16. This is -9 times 3, or minus 9 times 3, which is -27. Right here, it's -3 times -4, which is +12. Okay? You can throw it in a calculator, just do it in your head. Watch, let's do it in our head. It's -16 plus 12. I think that's the easiest part to do. -16 plus 12 is -4. -27 minus 4 is -31. Alright? Let's go on. Here's another evaluate problem, but this time we have absolute value. So what we're going to do is we're going to substitute those numbers in for x and y, and then we're going to figure out what's inside the absolute value. Remember, whenever you figure out what's inside the absolute value means you take the positive version of whatever that answer is. Alright, so we plug some numbers in here, see what we get. Plug the y in for this, see what we get. Take the absolute value of this, which means if it came out negative, then it turns into a positive. Now if it already comes out positive, you just keep it positive. So let's see what we get. Keep this absolute value symbol so we don't forget about it. So it's -5 times y, and y is 20, plus 2 times x, and x is 10. Alright, we'll do that in the next step. Minus absolute value of -6 times y, y is 20, All right, close the absolute value. Now, again, we work what's inside here. Don't take all the stuff that's negative and make it positive right now. Do not do that. It's not always going to work out correctly if you do it that way. Just work out the problem, then at the very end, then we'll take the absolute value of it. So let's see what we have in here. Negative 5 times 20 is negative 100, plus 2 times 10 is 20. That's the absolute value, minus, let's work this out. Negative 6 times 20 is negative 120. Let's do one more step before we actually take the absolute value. This is negative 100 plus 20, which is negative 80, minus, and we'll keep this just for the sake of doing the next step all in one shot. Alright, so here we go. Now we figured this thing out. We plugged the stuff in here, we came up with one number, now we apply the absolute value. The absolute value of negative 80 is positive 80. Remember, whatever's in here, it always comes out positive. Minus, and then we figure out what this is. The absolute value of negative 120 is positive 120, so that's 120. That's 80, that's your minus right here, that's how we got that minus, and this is just regular 120. So 80 minus 120 is negative 40. And that's how you work with absolute value. Okay, here's an addition problem. It says add the polynomials is what it says on the test. So you're just going to add up the things that are like terms. Okay, when you add, you can only add like terms. Look right here, you got a couple sets of parentheses. Don't let that fool you. This is not multiplication. This is a plus in between the two parentheses. So that means you're going to add them together. Now really, there's actually no need for these parentheses at all, because there's nothing being multiplied by this parentheses, there's nothing being multiplied by this parentheses. So really, if you wanted to, you could just get rid of the parentheses, and it just makes it a little bit easier. Now, if you had a negative or a regular number on the outside of that parentheses, then you'd have to work with it. You have to distribute that number through. But we don't have it in this situation, so now we can just add the like terms. So this is 6a to the fourth. I can only add a to the fourth to another a to the fourth. Do I have another a to the fourth? Yep, right there, a to the fourth. So this means I have 6 of these things. This means that I have 4 of these things. So I add them together. 6a to the fourth plus 4a to the fourth is 10a to the fourth. Alright, so I'm done with those. I've added those together. So look at the next one. This is negative 4a cubed. This is also a cubed. So I just add the coefficients and I keep the term the same. So it's negative 4 plus 7, which is positive 3. And then my term is a cubed. See, I'm not adding the 3 and the 3 together, or I didn't add the 4 and the 4 together or anything like that. Okay, I just add the coefficients and keep the rest of the term exactly the way it was. And I can't do anything else with that. They're not like terms. I can't add them any further. That's a to the fourth. This is a cubed. They're not the same, so I have to stop right there. Okay, even though this is under the umbrella, I guess, if you want to call it, of add, I consider subtraction the same thing as addition, because when you subtract, you're just adding the opposite. So really, addition, subtraction, kind of the same thing. Alright, let's take a look. I don't have anything in front of this parentheses. There's nothing being multiplied through, there's nothing being distributed through this. So in this particular case, I really don't even need these parentheses right there. But in this one, I absolutely do need these parentheses, because this negative, this minus, is being distributed through all 3 of these, and that's really important. Alright, so the parentheses is definitely important on this problem right here, because that negative has to go to all 3 of these. So let's just rewrite this one, because I didn't really change it at all, but I am going to change this last part. I'm just going to change the sign, because I'm just multiplying by a negative 1. So negative times a positive 9n squared is minus 9n squared. Then I have a negative times a positive, which is negative 2n to the 5th. Then a negative times a negative, which is positive, and that'll be a 2. Alright, so that's what that did. That negative just distributed through that parentheses. Now I can go back to what I did up here in this problem and add like terms. I always like to start with the highest power exponent first. That would be n to the 5th. Are there any other n to the 5ths? Yep, right here. So let's add those. 4n to the 5th minus 2n to the 5th is 2n to the 5th, because 4 minus 2 is 2. I like to mark them out so I know I'm done with them and I don't repeat them. What's the next highest power? N squared. So I'm going to add those together. I've got 11n squared minus 9n squared. So you just add the coefficients. 11 minus 9 is 2, positive 2, so we put a plus 2n squared. So that goes and that goes. And what else do we have? We got these constants. They're just the regular numbers. It's a positive 12, positive 2, add them up, and that's a plus 14. And that's all you have to do. Whoops, terrible circle. All right, you get the idea. There's you can't add those any further because that's the end of the fifth. That's an n squared. You just keep it like that. There's nothing else you can do with that. Okay, this problem is multiplication. This kind of has the same idea of what we did a little bit earlier with that negative sign. Remember we distributed that negative sign through here? What we're going to do is take negative 5a x to the 7th. We're going to distribute it. It's being multiplied by everything inside this parenthesis. So I take this times the first one, then multiply it by the second term, and then multiply it by the third term. So let's see what we get. And then if we can add like terms, then we'll add like terms. Sometimes you can, sometimes you can't. It just depends on the problem. So let's do this. Let's multiply these two together. So it's negative 5 times negative 10. Negative times negative is positive, and that would be a 50. Let's multiply the a's together. A times a. Remember, that's a to the first, and that's a to the first. The rule is you add the exponents. Keep the base the same and add the exponents. 1 plus 1 is 2. So a times a is a squared. Let's do the x's. X to the 7th, x to the 7th, x to the, what do? You add the exponents together. 14. So that's our first part. Now we take this times the second one. Again, it's negative 5 times negative 6, which is positive 30. Since it comes out positive, we put a plus. There's the 30. Then we do the a's. I've got an a here. Don't have any a's here, so it's just a. X to the 7th, x to the 4th, that's x to the 11th. Remember, we're adding the exponents. It's a multiplication problem, but the trick is, or the rule is, that you add the exponents together. Let's do the last one. It's negative 5 times positive 6, which is negative 30. It's a times a, which is a squared. We did that earlier. And then this doesn't have an x, but this does. It's x to the 7th, so I still need that x to the 7th. Now look to see if there's any like terms. This is a squared x to the 14th. This is just a x to the 11th. We know they're not like terms. And this is a squared x to the 7th. Even though it has a squared the same, x to the 7th here, x to the 14th here, they're not like terms. There's nothing else you can do with that. So you just circle it, and then that's your answer right there. This next one's still multiplication. Looks a little bit different because we got two parentheses being multiplied together. Now we gave it a little word. Remember the word FOIL, F-O-I-L, first, outside, inside, last. You can think of it that way, or you can think of it just like we did up here as distributive property. You took the first one and you multiply it by both of these things in this parentheses. Then you take the second one and you multiply it by both things in the parentheses. There you go. Everything's being multiplied now. You can think of it as FOIL, or you can think of it as just as regular distributive property. So let's do that. Let's use the word FOIL. Okay, a lot of you guys are used to that. So it's 7m times 4m. You multiply those together. So 7 4s are 28. M times m is m squared. Don't forget that. A lot of people tend to put just 28m. It's m times m, which is m squared. Now let's do the outside, these two on the outside. It's positive 7, negative 3, which is minus 21, and then you have an m here. So write that down. Now you got the inside. 2 and 4m, multiply those together, and that's plus 8m. And then the last is positive 2, negative 3, which is a minus 6. Now we're not going to leave it like this. Okay, we need to simplify it. Even though it just says to multiply, we always want to simplify our answers on here. If you just leave it like this, I'm going to mark it wrong because you were supposed to simplify. Even though it might not say it in the instructions, it's just kind of a given. All right, so negative 21 plus 8, what's that, 13? Negative 13m. Those are my like terms. I don't have any like terms with m squared, and I don't have any other just regular constant number. So I just leave it like this, and circle it, and we're done. Alright, this is kind of the same thing. We don't call it FOIL though, okay, but remember before when I did that distributive property, that's exactly the way we're going to look at it right here. We're going to take 4x, multiply it by these three things, right, because we've got three things. This is a trinomial. And then we'll take, after we multiply 4x by all three of these, and we'll take negative 12y and multiply it by all three of these as well. So there's actually 6 multiplications that are going along. And after we're done all that, we have to see if there's any like terms. If there's like terms to add up, we got to make sure we add up those like terms. All right, let's start. Let's do 4x times all three of these. So 4x times 2x is 8x squared. 4x times 7y is positive 28xy. And then 4x times 1 is just positive 4x. All right, so we took care of the 4x. Now we're going to do the same thing, but we're going to multiply everything over here by negative 12y. So negative 12y times 2x, which is negative 24. You could say yx. I kind of like to go in alphabetical order, so we'll put it xy. Let's do the next one. Negative 12y times negative 12y times 7y, and let's see, what is that? 84, right? Almost forgot my multiplication tables. So let's see, we got negative, and then it's going to be 84y squared. All right. And then let's see, then we do the last one. Negative 12y times 1 is just negative 12y. All right, let's see if there's any like terms. Let's look at the first one, x squared. Any others? Nope, no other x squareds there. So I just write 8x squared. So I'm done with that. What about xy? Yep, I do. There's an xy here. Now that just has an x, right? And that just has a y. But which one has an x and a y? This one right here. So it's 28xy minus 24. You just add the coefficients. 28 minus 24 is 4. So it's plus 4, and then the term is xy. So I'm done with that. All right, what about this? X. Nope, no others have an x, so I just write plus 4x. Done with that. What about y squared? Any other y squareds? Nope. So we just write minus 84y squared. Done with that. And then what else? Minus 12y. That's all you can do. It's not all that simplified. We only could actually add two things together here, but that's enough. And we're finished with number 9. All right, here's another one. This is actually very similar to what we did earlier with the FOIL method. It doesn't quite look like it, but remember, when you square something, you always multiply it by itself. So I'm going to take that 4m plus 11, because we're squaring that whole parentheses. So I take that whole parentheses and multiply it by itself. I almost hate to tell you this, but a common misconception is that you just take 4m and then you square it, and then you go plus 11 and then you square that. You don't do that. There is no distributive property for exponents, and a lot of people think there is. There's not. Okay, so what you do is you got to multiply it by itself, and you'll see a difference when you do it the correct way as opposed to just squaring the stuff inside the parentheses. So here we go. We multiply it by itself, and now we just do the FOIL method or distributive property. 4m times 4m, that's 16m squared. All right, and then that's plus 4m times 11, which is 44m. Then the inside is the same exact thing, so that's a plus 44m. And then the last is plus 121. Add some like terms. Well, 16m squared just stays like that. These are your only two like terms. You add those up and it's 88m. And then you got a plus 121 at the end. Alright, so the key to this problem is to change it to a FOIL method. Change this to two binomials being multiplied times itself. Don't go 16m squared plus 121. That's not it, because look, you're missing a big chunk of it, that 88m. So make sure that you do multiply it by itself, and then you'll be good to go. This problem is a FOIL method again, very similar to this, but look at this one. Everything looks almost identical to each other, except this is plus. I didn't write that. Oops. Let's make this a little bit better. Okay, that's a positive, and this is a negative. Up here, they were both positive. Down here, they're both negative. This is kind of like a difference of two squares, if you remember that. So when you have this situation right here, you know how we added these two together? We added them up, got 88m. If you have a situation like this, one would be positive and the other would be negative. And so the middle terms are always going to add up to 0. Just looking at this, when I see two parentheses and everything's the same except one's positive and this one in the middle is negative, once I see that, I know the outside and the inside are going to add up to 0. I don't even have to worry about doing that multiplication. All I got to do is the first and the last. So it makes this problem a lot easier if you can recognize that. So that's all I got to multiply are those two things right there. So let's do that. 12a times 12a, that's 144a squared. Don't forget, it's a times a, which is a squared. The outside and inside will add up to 0. Alright, if you don't believe me, you go ahead and try it. I'm not going to take the time. Just understand that the outside and inside will add up to 0. Let's do the last now. Plus 13 times 13, that's 169, I believe. And then c times c is c squared. Whoops, I messed up. Do you see where I messed up? Right here. Because positive times negative is negative. All right, that's not a plus right there, so forgive me for that. At least I caught it. There you go. That's your answer right there. There's nothing else you can do with it. All right, it's been a little while since we've done this one, but if you go back and look at the video to this, I forget exactly what section it's on, but you could probably find it. We'll do this right here anyway. But if you remember, this is that binomial expansion problem. So we had a little trick. We use this thing called Pascal's Triangle. So we'll do the triangle real quick. Remember, it starts off with a 1 at the top, then you got 1s on the ends. And now, you keep having 1s on the ends, but what do you do to this 1 and 1? You add them up, stick it in the middle, that's a 2, and you stick another 1 on the end. Okay, put a 1 on the end, add these two up now, which will give you a 3. Add these two together, that'll give you a 3, stick a 1 on the end. Let's do it again. Put a 1 on the end, add these two together, 1 plus 3 is 4. Add these two together, that's 6. Add them, 4, stick a 1 on the end. Let's do it one more time because we're going to the 5th, so let's go to the 5th. So we got a 1 on the end, add these, which is 5, add these, 10, add them, 10, add them, 5, stick a 1 on the end. This is what we're going to use. Now, what in the world are those numbers doing for us? These are actually the coefficients to each of the terms in this expansion, this binomial expansion. You'll see what I'm talking about in a second. Now remember, this is x plus 5 or x plus y times x plus y times x plus y 5 times. All right. You could sit there and write them all out 5 times and then do the multiplication. You could do that. It would work if you did it right, but there's a lot of places where you can mess up. This is just a little quicker, a little easier. So first thing we do is look at our first coefficient, and that would be the x. Remember, we start with this, so this will be x to the first. Or yeah, we got a 1, I'm sorry, it's 1, then it's going to be x to the 5th. We always start with that. Now technically, there is a y there, but it's y to the 0. What is y to the 0? It's a 1. So I can just keep this x to the 5th like that. Plus, look at the next coefficient. It's a 5, so I put a 5 right here. Watch what happens to this x. Remember, I'm not going through a complete explanation of why this happens. We did that when we first taught the lesson. But do you remember the little pattern here? It starts x to the 5th, and then the x goes down. Remember, this was a y to the 0. What happens now to the y's? They start moving up, so now it's y to the 1st. So I didn't write it there, y to the 0, but you could if you wanted to. There's just no need to do that. So it's y to the 0, then y to the 1st. All right, and then you just continue that pattern. Here's your coefficients. You continue that whole pattern until you get to that last coefficient. The next one is a 10, so it's plus 10. What happens to the x? That goes down by 1, and then the y's go up by 1. This is y to the 1st, so that becomes a y to the 2nd. Next coefficient is a 10, so put a plus 10 here. The x's go down, so that's going to be x squared, and the y's go up. That's going to be y cubed. Then we've got a 5. Hopefully I have enough room here. What happens to the x? It keeps going down. It was x squared, so now it's x. The y's keep going up. Y to the 3rd becomes y to the 4th. All right, plus, and then your coefficient is just a 1. Look what happens. The x goes down to x to the 0, which is a 1. What happens to the y? It keeps on going up, and that's a y to the 5th. And that's your answer right there. You don't really need this 1 out in front. I mean, you could have it, it wouldn't be wrong, but you don't need it. So that whole crazy thing right there is your answer. Okay, now we're going to do a division problem. It says to divide this, x squared plus 11x plus 20 by x plus 4. We're going to write this as a long division problem. Put the x plus 4 on the outside. Okay, and then we'll put this inside. So that's going to be x squared plus 11x plus 20. And now you work this as you would like a regular long division problem. So you say, how many times does x go into x squared? Again, if you're not really sure, I come off to the side. How many times does x divide into x squared? Don't say 2. A lot of people say 2. It's not. This is x squared over x to the 1st, which is just an x. So how many times does x divide into x squared? X times. Now we multiply, then we subtract. I always like to put my subtraction first, put a blank parentheses, now I can multiply. Now remember, I'm taking this x, I'm multiplying it by this whole thing on the outside. If you want, you could put it in parentheses to remind you to distribute it through. So if I multiply it through here, what do I get? I get x squared plus 4x. All right, let's see what happens. X squared minus x squared is 0. 11x minus 4x is 7x. All right, drop down the next number. And now we say, how many times does x divide into 7x? How many times does x go into or divide evenly into 7x? Well, that goes exactly 7 times, because watch, that x cancels out with that, and that's 7 times. So I've got plus 7. Take the 7, multiply it by here, and then subtract it. I put the subtraction, then the parentheses. Make sure you distribute when you multiply that 7 by the x plus 4. So I've got 7x plus 7 times 4 is 28. Okay, 7x minus 7x is 0. 20 minus 28, that's negative 8. And yep, that's my remainder. Because x doesn't divide into negative 8 evenly, so I put minus. Since it's a negative 8, I put a minus, and I put 8 divided by x plus 4. That right there is your answer. Okay, this one's a little different. We're actually going the other way. We're actually not multiplying something together. We're actually going to divide something out of here. And that's factoring. Okay, factoring. And this one says factor the greatest common factor. That's really the only way you can factor this thing. So let's find the greatest common factor. Well, I got 3 numbers. Just look at the numbers right now. Forget the letters. Look at 160, 64, and 32. When I say greatest common factor, I want to find a number that divides evenly into all 3 of those numbers. What's the largest, the greatest number that divides evenly into all 3 of these numbers? Well, let's think. What's a small number? 2. 2 goes into all of those. 4 goes into them. Let's see, 8 goes into them. Even 16, even 32, right? 32 goes into this, 32 goes into this. And if you do a quick little calculator work, 32 does divide evenly into 160. And that's the largest thing that divides into all of those. So 32 is my greatest common factor with these regular numbers. What about the variables? I get x to the 8th, x to the 5th, x to the 3rd. Okay, well the number that divides evenly into all 3 of them is the smaller of those 3, and that would be x cubed. With the y's, y to the 9th, y to the 6th, y to the 4th, again it's the smaller of those 3, so it's y to the 4th. That's my greatest common factor. But don't stop right there, because it does say to factor it, okay? Which means I want to find out what's left over after I factor it out. Basically what I'm doing is I'm taking each of these terms and I'm dividing by this greatest common factor. It's kind of like the opposite of distributive property. So let's do this. 32 goes into 160, or 160 divided by 32, and that's 5. X to the 8th divided by x cubed. Remember the rule for division with exponents? You subtract the exponents from each other. So 8 minus 3 is 5. So this is x to the 5th. Then y to the 9th divided by y to the 4th, same rule. Subtract 9 minus 4, and that's 5 as well. And let's see what else is inside of here. Put a plus, because that plus. Let's take this second term and divide it by this greatest common factor. So 64 divided by 32 is 2. X to the 5th divided by x cubed is x squared. Y to the 6th divided by y to the 4th is y squared. That's that one. The next sign is minus. Now we take this last term, divide it by this greatest common factor. So 32 divided by 32 is 1. X cubed divided by x cubed is 1. Y to the 4th divided by y to the 4th is what? 1. Right. So what do I have? I didn't write them all down, but we remember it's 1 times 1 times 1. What's 1 times 1 times 1? It's 1. Don't leave a blank. Don't just leave nothing. Don't just say, well, nothing goes into it. Sure it does. 1 goes into it. So you need that 1 there. That's very, very important. And if you wanted to check yourself to see if you did it right, you could always take this greatest common factor, multiply it by all 3 of these things, and you should come out to what you started with. Alright? And that's your answer right there. Okay, we're going to do some more factoring, and this is a different type. It even tells you what type it is, and it makes it a little easier to figure out what to do. By grouping. So what we're going to do, if you look at this, there's nothing that's in common with all 4 of these at the same time. But if I group these 2 together, and I group these 2 together, there is a greatest common factor with these 2, and there is a greatest common factor with these 2. So that's what I'm going to do. So let's figure out what this one is. What goes into 10 and 4? Well, only 2 does. What about this? A cubed, a squared. We take the smaller one, so that's a squared. Now there's not a b that's in common, so I can't pull that out. So let's figure out what's left over. I factor out a 2a squared. 10 divided by 2 is 5. A cubed divided by a squared is a. Minus 4 divided by 2 is 2. A squared divided by a squared is 1. And then you have that b, so you put the b right there. That's a weird looking b, isn't it? Let's try to make it look a little normal. There we go. Alright, so all I did was take those first two terms and factored out the greatest common factor, just like I did up here, just a little easier here. Plus, let's figure out what's in common with these two. Well, I got 15 and 6, so let's see, 3 is in common with both of those, so I factor out a 3. There's no a in common with both of them, but I do have b's. I got a b squared and a b cubed, so b squared is in common with both of those. Take this and divide it by 3b squared, so 15 divided by 3 is 5. I don't have an a here, so I'm just going to leave the a. B squared over b squared is just a 1, don't worry about that. Minus 6 divided by 3 is 2. B cubed divided by b squared is b. Alright, now we're not quite finished, because if you look at this right here, and look at this right here. Is there something in common with both of these? Sure there is. There's a 5a minus 2b here, and there's a 5a minus 2b right there. So that's in common. That's a greatest common factor, so I factor out 5a minus 2b. If I take this whole term right here and divide it by 5a minus 2b, what am I left with? 2a squared. Notice I put a parentheses here, and it's being multiplied by this stuff. Put a plus. Factor out a 5a minus 2b from this. What do I have left over? 3b squared. And that's it. That's my answer right there. Don't stop short on these. Make sure that you factor it completely all the way down to this. Alright, now we're going to factor a trinomial. Alright, it's not just any trinomial, it's an x squared, x, and a constant type of trinomial. So this is where we put the two sets of parentheses, and then we just kind of figure out, it's kind of like the backwards of FOIL method. So I got to figure out what times what is 8x squared, and this right here, this last times this last right here is going to be 5, and then the 2, and then you got to figure out if your middle term is right. So we have a couple ways to do this. If you remember, we had like a guess and check method kind of way. I don't know if that was the official name for it, but that's what I called it. So we got to figure out what times what is going to give you 8x squared. So we got a couple things. We got 8 times 1, you got 2 times 4, or you could switch it around. You can go 1 times 8, or you could go 4 times 2. Let's just go 4 times 2. Alright, so I got 4x, and I've got 2x. Because remember, it's FOIL method. First, outside, inside, last. So the first, these two multiplied together have to be 8x squared. That's why I picked 4x and 2x, because 4 times 2 is 8. And that's just a guess. It could be 8 times 1. I don't know. I don't know, to me, just popped in my head, 4 times 2 is 8. Then, the last. So this times this has to be 5. Well, first of all, let's look at the signs. They have to multiply to be positive and add up to be positive. That means they're both going to be positive. Now, this could be 5 times 1, or it could be 1 times 5. Let's try 1 times 5. Let's see if it works. Now, when I say see if it works, that means this whole thing has to work. We already figured out that the first is 8x squared, so we know that works. We already figured out that 1 times 5 is 5, so we know that that works. It's this part right here, the O and the I, the outside and inside. So I have to multiply the outside, multiply the inside, and what's it have to do? It has to add up to be 14x. Let's see if it does. That's what I mean by let's see if it works. Let's take the outsides. That would be what? 20x. Let's take the inside, which would be 2. 20 plus 2 is 22. Is that 14? Nope, it's not. So that doesn't work. So I got to try something else. I'm okay with the 4 and 2. Let's just try the 1 and the 5. And now there's nothing else that multiplies to be 5 except for 1 times 5. But I could change the order of the 1 and the 5. Let's see if that works. So let's try it. Now again, I'm fine with the first and I'm fine with the last. It's the outside and inside that I'm checking. So watch, here's the outside. 4x times 1, that's 4x. And then 5 times 2 is 10, so 4 plus 10 is 14. Yep, that's exactly what I'm looking for right there. I'm looking to see if the outside and the inside add up to be the middle term right here, and they do. And so now I and finished. Sometimes you get it on the first shot. Sometimes it takes you 3 or 4 times, depending on how complicated this is. But we got it on the second shot. Not too bad. All right, they really help you out on this one. It says factor the perfect square trinomial. So you know it's a perfect square. I'm not going to get a lot of background on this, but I'll give this much. A perfect square is basically this. It's like if I had something like that. That would be a perfect square. If I had a parentheses with a squared on the outside, that's a perfect square. Now, if I multiplied this out, this is what I would get. I would get x squared plus 2xy plus y squared. So what I want to do, if I take the coefficient here, okay, if I took the coefficient here and here, multiplied them together and doubled it, I'll get the coefficient in the middle. That's one way to check to see if it's a perfect square. So let's come over here. Now this is my coefficient to m squared, but watch, I could write it like this. I don't want to get too confusing. And then I can write that as 7 squared. I want to show you why I'm doing that, because watch. Here's a way to test to see if this really is a perfect square. Now they told you in the problem it's a perfect square, but what if you saw one out in the wild, okay, and you weren't really sure that it was a perfect square? Here's one way to try it. If this thing is being squared, if something's being squared to give you this and something's being squared to give you this, you're off to a good start. But what am I going to do? I'm going to take the coefficient, that 5, and that 7. What is being squared? The number that's being squared is a 5. The number that's being squared here is a 7. Multiply them together and double it. Well, 5 times 7 is 35. If I double 35, I get 70. And so, yeah, it works. All right, so if I take this and double it, or I take this, multiply it by this, and double it, and if it's that middle term, yes, that's a perfect square. It's kind of nice to write it like this, because what is a perfect square? A perfect square looks like this. Now, since you have a sign in the middle is negative, I can put a minus right here. Now, what's being squared to give you 25m squared? A 5m is being squared. What's being squared to give you 49? A 7 is being squared. And there it is. Just like that. I hope my explanation seemed a little bit weird. I don't know. But you can go back and look how I explained it when I first taught this lesson if you like. But anyway, that was alright. Okay, let's look at number 18. Factor the difference of two squares. Now, this is actually one of the easiest factorings you can do. That's supposed to be equal sign right there. Alright, this is a difference of two squares. So what I'm going to do is kind of like what I did earlier in number 17. I find out what is being squared to give you this. Well, what's being squared to give you 81? Well, 9 is. What's being squared to give you y to the 4th? Well, y squared is being squared. So watch, I take this. This makes things a little bit nicer for me. Alright, so that's being squared. What's being squared to give you 4? Well, 2 is being squared. Now watch what we do here. Since this is being squared and this is being squared, this is a difference of two squares. So what I can do, again, I'm not giving you a lot of background on this because we taught this earlier, but one parentheses is plus and the other one is minus. So look what we have. Whatever's being squared goes right here, 9y squared. And whatever's being squared on the second one goes right here. The two parentheses are exactly the same, with the exception of one is plus and one is minus. And there you go. That's the difference of two squares. Okay, I know we did this in class, but I'm going to do it again just for fun, okay? This is the sum of two cubes. Before we even do the sum of two cubes, let's write down the little formula. Okay, now these letters don't really, well, they do have something to do with this, but anyway, I'm just writing down the little formula that we learned that you should have memorized for the sum of two cubes. And it looks like this. So that means if I had a cubed plus b cubed, that's the sum of two cubes. This is how it would factor if I was to factor it out. It's two parentheses. That's how I started off. Then I do my signs. Remember my signs. I've got two things in here, two terms in this, and I got three terms in this. So it's going to be separated by a sign right here. So it's always the same, opposite, positive. Same, opposite, positive. It's the same sign as this. Well, that would be positive. The opposite sign of this, that would be negative. And this one would always be positive. So watch what goes in here. A and b, and then a squared and b squared, and then inside would be a, b. So that's my formula. I'm going to use that formula to factor this thing right here. First of all, you got to look at how's it set up. It's something squared. So I want to rewrite this. I've done this in the last two problems. I want to rewrite this. I said squared, didn't I? I meant cubed. It's something cubed. So what cubed is 125? Well, 5 cubed, right? 5 times 5 is 25 times 5 is 125. What is being cubed to give you x to the 12th? Well, x to the 4th is being cubed. This is how I want to write it, like this. That's the thing that's being cubed. It's important that you write it like this because we want to find out what is being cubed. Over here, what was being cubed here? Well, just a. What was being cubed here? Just a b. This is a little more complicated than this, but it's the same basic idea. What's being cubed to give you 8? Well, a 2 is. What's being cubed to give you y to the 6th? Well, y squared. If I take y squared and cube it, then I would get y to the 6th. All right? Because remember, when you take an exponent to another power, you multiply those exponents together. Now look, knowing this little formula right here is very, very nice because that right there is where I'm going to put it in for a. Anytime you see an a there, that's what I'm putting it in for. Okay, 5x to the 4th. And then my b is 2y squared. So anytime I see a b over here, I'm going to stick in a 2y squared. So now let's work this thing out. So I've got two sets of parentheses. I'll give myself a little bit more room because there's a little more than just a and b. Do the signs first. This is positive, so it's same, opposite, positive. So that's same, that would be opposite, and this would be positive. Now let's put the numbers in. This is a and b. Well, what's my a? My a is not just a this time. What is it? It's 5x to the 4th. That's my a. And then this would be the b. What's the b over here? It's 2y squared. It's kind of like substitution, just substituting these numbers in for a, substituting that in for a, and substituting this in for b into this formula. Let's do the a squared. Well, this was a, but now I got to square this thing. So I got to square 5, which is 25. And then I have to square x to the 4th. X to the 4th squared is x to the 8th. I always like to do this one next. Do the b, square that. Take 2 and square it, which is 4. Take y squared and square it. Y to the 2nd is y to the 4th. And now, how do you find the middle? You just multiply these two things together. 5 times 2 is 10. And then you just have x to the 4th and then y squared. So it's basically just a matter of knowing this formula. You really got to know this formula. If you don't know this formula, then you're sunk. You got to know this. It's not that hard. We've done it lots of times. So good luck with that. One more problem to do and we'll be finished. All right, this one says factor by substitution. This kind of looks like one of those trinomial factoring. I forget which number that was. It was like number 16, I think. With the exception, this is not just a z squared or an x squared. And this is not just a z or just an x or just an a or whatever letter you want to use here. This is z to the 4th. So what we're going to do is we're going to say let right here. This would be really nice if this was just like a 3x and this was a 20x squared, because then it would look like what we're used to. So what I'm going to do is I'm going to say let x equal z squared. So instead of writing 3z squared, it'd be really nice if I could just say 3x. So that's what I'm doing. I'm replacing z squared with an x. Well, if I replace z squared with an x, this would be z squared squared, right? So this would be x squared. So what I can do is I can rewrite this now, and I can write it 20x squared plus 3x minus 9. This looks a little more familiar with me when I want to factor this thing. So what I'm going to do is I'm going to do a regular trinomial factoring, do that guess and check deal. Now, if I multiply these together, it becomes negative, and if I add them, it becomes positive. So I need to have one positive and one negative. Because when I multiply two numbers together and get a negative answer, you always have to have different signs, one positive, one negative. Alright, so let's see what I want to use. Now, I already know the answer to this, so I'm just going to write down these numbers. I'm going to use 4 and 5. So I'm going to use 4x and 5x, and I'm going to use 3 and 3 right here. Right? Just pretend I got real lucky and got it right the first time. How do I know if I got it right? Well, I know the first is right because that's 20x squared. I know the last is right. It's negative 9. What about the inside? Well, I take the outside and inside. So that would be 4x times negative 3 is negative 12x plus 15. Negative 12 plus 15 is positive 3. Yep, sure enough, it works. Well, It is factored, but I didn't factor this, did I? I got x's in there. That doesn't have x's in there. So what I'm going to do is come back to this. Wherever I see an x, what am I going to do? I'm going to replace it with a z squared. So I'm going to write 4, instead of 4x, it's going to be 4 what? Z squared. Then just put the plus 3. And then instead of 5x, it's going to be 5, what did we say x was? Z squared. So I'm just going to replace that x with a z squared and put minus 3. Now, that is the answer to this one right here. We kind of took like a side road a little bit, and then we got back on the right road by replacing it with the z squared. All right, well, I hope that helped you out. That's a lot of stuff, but and we've already done 1.5 to 1.7. We answered all your questions in class, so I'm not going to do one of these for 1.5 to 1.7 because we took care of all your questions in class. So I know we didn't hit every single problem, but I told you we would just take questions in class. All right, good luck on your midterm. See you tomorrow.